Hello student, good morning. Today I am going to discuss particle nature of electromagnetic radiation, and we will focus on Planck's quantum theory. Some of the experimental phenomena such as diffraction and interference can be explained by the wave nature of the electromagnetic radiation. However, some of the observations which cannot be explained with the help of even the electromagnetic theory of 19th century physics known as classical physics. What are that points? Then there are 4 points that can't be explained by even from electromagnetic theory. Then first point, that is the nature of emission of radiation from hot bodies. Hot bodies is also known as black body radiation. Second point, ejection of electron from a metal surface when radiation strikes in photoelectric effect. We will tell what is a photoelectric effect. Then second point, that which can't be explained, ejection of electron from metal surface when radiation strikes it. Third point, variation of heat capacity of solid as a function of temperature. And fourth point, line spectra of atoms with special reference to hydrogen. These 4 points can't be explained by the use of electromagnetic theory of 19th century known as classical physics. Classical means old. It is noteworthy that first concrete explanation for the phenomenon of the black body radiation was given by Max Planck in 1900. This phenomena, what was that phenomena? Maxwell Planck in 1900 given some theory. Actually, to explain all these 4 points, this Maxwell Planck's given one theory, and that is I am going to discuss. Explanation how Planck has given explanation for that, for this 4 points which was not able to discussed by the classical physics. Then this concrete explanation for the phenomenon of the black body radiation was given by Max Planck in 1900. Then what was that phenomena? That I am going to discuss. Means I am talking about the black body radiation. When solids are heated, they emit radiation over a wide range of wavelengths. For example, when an iron rod is heated in a furnace, it first turns to dull red and then progressively becomes more and more red as the temperature increases. As this is heated further, the radiation emitted becomes white and then become blue. Radiation emitted becomes white and then becomes blue as the temperature becomes very high. In terms of frequency, it means that the frequency of emitted radiations goes from a lower frequencies to higher frequency as the temperature increases. The red color lies in the lower frequency region, while the blue color belongs to the higher frequency region of the electromagnetic spectrum. The ideal body which emits and absorbs radiations at all frequencies is called a black body, and the radiation emitted by such a body is called black body radiation. The exact distribution of emitted radiation that is the intensity versus frequency curve of the radiation. This you have to understand, the exact frequency distribution of emitted radiation, that is the intensity versus frequency curve of the radiation. Then from a black body depends only on its temperature. At a given temperature, intensity of radiation emitted increases with decrease of wavelength. Decrease of wavelength means increase of frequency. Increase of frequency means increase of energy. Then at a given temperature, intensity of radiation emitted increases with decrease of wavelength, reaches a maximum value at a given wavelength and then starts decreasing with further decrease of wavelength. Then actually this decrease of wavelength means increase of frequency, or increase of frequency means increase of energy. The above experimental results cannot be explained satisfactorily on the basis of the wave theory of light. Actually there are many theories, but main two theory is wave theory of light. Wave theory of light means it tells about the in the wave theory, position of matter will not change, only energy will transfer from one matter to the matter will be the same, but energy will be transferred. In wave matter will be fixed. There will be no transfer of matter, only energy will transfer. That is actually wave theory. But in 1900, what I discussed in details, electromagnetic theory, that is different. Already I have discussed in details electromagnetic theory, that is related to electromagnetic wave, means electrical and magnetic wave field, electrical and magnetic field in the form of wave. Now Planck suggested that, now important point I am going to tell, this phenomena that what I discussed now, that intensities versus frequency curve. Related to that, what this Planck's told, that I am going to, important point I am going to tell. Planck suggested that atoms and molecules can emit or absorb energy only in discrete quantities, fixed quantities, and not in a continuous manner. Actually, it was believed in that time that it will emit or absorb continuously. But what he told, Planck suggested that atoms and molecules can emit or absorb energy only in discrete quantities and not in a continuous manner. Planck gave the name quantum in the smallest quantity, quantum. Planck gave the name quantum to the smallest quantity of energy that can be emitted or absorbed. This is very, very important point. Planck gave the name quantum to the smallest quantity of energy that can be emitted or absorbed. In the form of electromagnetic radiation, the energy which is denoted by capital E, the energy E of a quantum of radiation is proportional to the frequency, means nu, and is expressed by equation E is equal to h nu, means energy E is directly proportional to nu, means frequency. And if we make it in a equality form, then it will come E is equal to h nu, a small h. The popularity, this h is called proportionality constant, that is called Planck constant. The proportionality constant h is known as Planck constant and has the value. What is the value of this h? Then this h value, that is called Planck constant, its value is 6.626 into 10 to the power minus 34 joule second. With this theory, Planck was able to explain the distribution of intensity in the radiation from black body as a function of frequency or wavelength at different temperature. This actually Planck quantum theory, this is called Planck quantum theory, and this theory became very, very useful, and only with this theory Planck was able to explain the distribution of intensity in the radiation from black body as a function of frequency or wavelength at a different temperature. Now I am going to discuss photoelectric effect. This is again very, very important term, and always question is asked. In 1887, H. Hertz performed a very interesting experiment in which electrons or electric current, actually you should know, flow of electron is called current, or also flow of charge is called current. Okay, now again I am continuing this concept. You should know, flow of electron is called current, and also flow of charge in solution is called current. Here again I am coming to the point. In 1887, H. Hertz performed a very interesting experiment in which electrons were ejected when certain metals, as for example potassium, rubidium, cesium, etc., were exposed to a beam of light. Means, again I am telling you that when light was exposed to potassium or rubidium or cesium, what happened? After exposing the light, then electrons were ejected from their surface. Electron came out when certain from the certain metals. I have given the examples. As for examples, potassium, rubidium, cesium, from their surface electron ejected when exposed to a beam of light. This phenomena is called what is called photoelectric effect. This phenomenon is called photoelectric effect. What is actually this effect? Then I told you the results observed in this experiment, where I am telling you results of this experiment. First result, the electrons are ejected from the metal surface as soon as the beam of light strikes the surface. That is, there is no time lag between the striking of light beam and the ejection of electron from the metal surface. No time gap. No, that is called a lag of time. Second, the number of electrons ejected is proportional to the intensity or brightness of light. Third, for each metal there is a characteristics minimum frequency nu, also known as threshold frequency. What is the threshold frequency? Again you listen. For each metal there is a characteristics minimum frequency that is required to eject the electron. That is called, that energy or that frequency is called threshold frequency, below which photoelectron effect is not observed. At a frequency V, means nu greater than nu 0. Here nu 0 is called are represented by, for threshold frequency is represented by nu 0, minimum energy which is required to eject the electron, nu 0. Then this is clear that at a frequency when nu is greater than nu 0, the ejected electrons come out with certain kinetic energy. The kinetic energy of these electrons increases with the increase of frequency of the light used. These 3 points, 3 results I have told you. Now come further. All the above results could not be explained on the basis of law of classical physics. That's why when classical physics failed in explaining all these points, Planck theory came in front. According to latter, the energy content of the beam of light, listen carefully, According to latter, the energy content of the beam of light depends upon the brightness of the light. Beam of light depends upon the brightness of the light. In other words, number of electrons ejected and kinetic energy associated with them should depend on the brightness of light. Actually, when light strikes on the metal, then energy is ejected, and when electron is ejected, and when electron is ejected, it will be in motion. It means it has a kinetic energy. It comes out with energy, that is called kinetic energy. Here we are talking about that energy. That number of electrons ejected and kinetic energy associated with them should depend on the brightness of light. It has been observed that though the number of electrons ejected does depend upon the brightness of light, the kinetic energy of the ejected electron does not depend. Again here, important term is there, important sentence, just is meaningful. Again you listen. It has been observed that though the number of electrons ejected does depend upon the brightness of light, the kinetic energy of the ejected electron does not depend upon the brightness of light. For example, red light, whose frequency is coming around 4.3 to 4.6 into 10 to the power 14 hertz. For this red light of any brightness, any brightness means here brightness is called intensity. Red light of any brightness, already told you, it's this frequency is between the 4.3 to 4.6 into 10 to the power 14 hertz, may shine on a piece of potassium metal for hours, but no photoelectrons are ejected when red light is used. But as soon as even a very weak yellow light, whose frequency is more than red, that is between 5.5, approximately 5.1 to 5.2 into 10 to the power 14 hertz. Actually both have the same 10 to the 14 hertz, but little yellow light has little more, 5.1 and to 5.2, but red was 4.3 to 4.6, less energy. But for but as soon as even a very weak yellow light shine on the potassium metal, the photoelectric effect is observed. The threshold frequency, that is a new zero, for potassium metal is 5.0 into 10 to the power 14 hertz, threshold in frequency, which it is getting in yellow light. Einstein was able, that is in the year 1905, Einstein was able to explain the photoelectric effect using Planck quantum theory of electromagnetic radiation. See, electromagnetic theory we have discussed in details. Now under that, Planck has given theory. Planck has suggested That suggestion is called Planck's idea, whatever you can tell, Planck's quantum theory of electromagnetic radiation. As a starting point, this Einstein was able to explain the photoelectric effect using Planck's quantum theory of electromagnetic radiation as a starting point. Shining a beam of light on the metal surface can therefore be viewed as shooting a beam of particles. The photon. Chaliye, light is also called photon, all called packet of energy. Then here, shining a beam of light onto a metal surface can therefore be viewed as a shooting a beam of particles, that is called packet of energy, also called photons. When a photon of sufficient energy strikes on an electron in the atom of the metal, it transfers its energy instantaneously to the electron during the collision, and the electron is ejected without any time lag or delay. Greater the energy possessed by the photon, greater will be the transfer of energy to the electron, and greater the kinetic energy of the ejected electron. In other words, kinetic energy of the ejected electron is proportional to the frequency of the electromagnetic radiation. Since the striking photon has energy equal to h nu, and the minimum energy required to eject the electron is h nu 0. Always keep in mind, nu 0 is the minimum frequency required to eject the electron. Then h nu 0 is the, you can say, total minimum energy which is required to eject the electron. Nu 0 is the frequency, h nu 0 is energy. Also called this h nu 0 is, that is the energy. Nu 0 is frequency, h nu 0 is energy. Keep in mind. This is also called work function, W0. W means work, W0. This is the actually minimum energy required to eject the electron. Now, then h nu is the energy of photon which is striking on the metal, and h nu 0 is the kinetic energy. Then that means not kinetic energy, minimum energy. h nu 0 is the minimum energy required to eject electron, and h nu is the energy of photon which is striking on the metal. Then difference between the two, these two energies is the energy required to remove the electron from the metal surface. That actually this difference of energy, the difference of energy or difference in energy h nu minus h nu 0 is therefore the kinetic energy. This difference is called kinetic energy of the photoelectrons. Then, following the conservation of energy principle, the kinetic energy of the ejected electron is given by the equation h nu is equal to h nu 0 plus half mv square. half mv square is kinetic energy, you know. Half mv square. mv are also called me, mass of electron. me means mass of electron. Half mv square means h nu minus h nu 0 is equal to half mv square. Then you also can write h nu is equal to minus h nu 0 is there, bring to the right side, then minus will become plus h nu, minus h nu will become plus h nu plus half mv square means me v square. Means you can tell h nu is equal to h nu 0 plus half mv square means half m small e v square means mass of electron, where m is the mass of electron and nu is v is the velocity associated with ejected electron v, small v, which is similar to nu. Looks same, but one is frequency nu, other is b. b is the velocity associated with ejected electron. Lastly, a more intense beam of light consists of larger number of photons. Again, in the last you should understand. A more intense beam of light consists of larger number of photons. Consequently, the number of ejected is also larger as compared to that of an experiment in which beam of weaker intensity of light is employed. Means, very simple way, a more intensity beam of light consists of large number of photons. Consequently, if means large number of photons are applied, then number of ejected electron will be also large. Then this I have discussed about the photoelectric effect, and also I have discussed Planck quantum theory. Both are most important, and at higher level, this in any competitive examination at higher level, this question is asked. Even in a sometimes in a tough competition, this may be asked. Then today I am stopping only here. Next lecture again we will meet. Thank you.